All right, last section is about what's called a dilation. Um, Hopefully you know what it means to dilate something. You know, when you go to the optometrist to get your eyes looked at, they dilate your eyes, meaning they're growing them out. Uh, when you're giving birth, you become dilated, which means things are getting bigger. So dilations are really just taking something and changing the size of it by and keeping its shape. So it's a proportion, just like we've been talking about. It has its own scale, which is how much you're increasing or decreasing it by, and we're just doing this on a coordinate plane instead. So it's using graphs to increase or decrease a shape. So let's say I have this triangle ABC with points at 1, 2, negative 1, 1, and 2, 1. I want to dilate by a factor of 2. Or you can also put it as perform the dilation 2x, 2y. Those are the same thing. It's just different ways of writing it. You've seen this before, basically. That's kind of when we're doing rigid motion, except for they weren't rigid motions because we're multiplying, and that's okay now. So um, we are dilating from the origin, which means we're dilating from the middle, and we'll kind of talk about what that means in a second. But really, all you're doing is you're multiplying or dividing the distance from 0, 0, which really means you're just multiplying the numbers. So I want to dilate by a factor 2. You multiply everything by 2, which is going to give us some new points. So 2, 4 is over 2 up 4. 1, 2, 3, 4. And I see nothing. Over 2 up 4. Still see nothing. Hold on. Technical difficulties. Alright. I should have put that layer up somewhere else. So let's get rid of that. Alright, 2, 4. Over 2 up 1, 2, 3, 4. That's going to be a, oh wow. There's a delay. That's my excuse. Then negative 2, 2. Negative 2 up 2. That's going to be B prime. And then 4, 2 over 4 up 2. And that's going to be C prime. So we come up with basically a shape that's twice as big. Easy enough. And what I mean by we're multiplying the distance from 0, 0, what's happening is, you know, there was an original distance, and we could calculate that using distance formula, but I'm just going to do this the easy way. Over 1 up 2, right? This was over 1, 2, up 1. And this was over 1, 2, 3, over 2, over 1 up 2. Oh my gosh. One, I don't have my glasses on, so it's kind of hard for me to see. Also, these are actually welding goggles, so everything's really dark. So, you know, there's a distance. And all that's changing is we went over 1 up 2. So I went over 1 up 2. Now I can go over 1 up 1. Over 1 up 1. Oh my gosh. So over 1 up 2 is what I was talking about. Over 1 up 2 to get to that point. And this one was over 2 up 1 and go over 2 up 1. Which that looks really, really messy. But really, we're just double counting. So, like I said, over 1, up 1, over 1, up 1 is all we did. Another thing you can do to tell if you did it correctly is it should always fall in a straight line. Straight line. Straight line, and then a straight line. So you can tell if you did it right if they're all in a straight line together. So all I did is I really literally just multiplied the numbers. Another way of looking at that is if we had this picture of Keelik, right? And I wanted to dilate this by a factor of, let's type this out. That's probably going to be way easier. Dilate by a factor of 1/2, right? So if I'm asking you to dilate by a factor of 1/2, really all I'm doing is asking you to find half of the points. So here we have the point 2,8, so you'd cut that in half. It should become 1,4. Over here we have the point, it's hard to see, maybe that's 8,6, and then we have over here that's up 16 over 8, right? Boom. And so I've cut it in half already, right? Half of 2,8 was 1,4. Then we have 4,3, so that was 8,6, and then we got 4,8. So by cutting it in half, we're literally just dividing the points by 2 instead. And it's literally that easy. So dilations aren't too bad. There's only one thing that kind of makes it complicated. And that's when I ask you to dilate something, but not from the origin. So on this one, we started from the middle. This one, I'm saying dilate from point P, which makes it a little bit different. But still not too bad. So remember up top here, I just counted over 1, up 1, then over 1, up 1. So I did that once, twice, because there's a factor of 2, right? I counted over 1, up 2. That was once. Over 1, up 2, twice. So we're literally really just doing the same thing on this one. So when I say dilate from point P, and the only reason I have those points there is so you can see them if you're graphing them on your own, all we're really doing is counting. So, and it said dilate by 3. So we got to remember that. Oh, oops, I have it picked. Dilate by 3. Okay, so I count over 1, up 1, 2. So then what I would do to get by dilate by 3, so I'm going to count over 1, up by 2, over 1, up by 2. And I did that once, twice, 3 times, because there's dilating by a factor of 3. So to dilate, literally all we have to do is count. You know, it's going to look messier on my notes just because I'm doing it all together. So now if I want to count at this point, it's going to be a little bit more difficult. I'm going to count over 1, 2, up 1, 2, 3, 4. So I got to count over 2, 1, 2, 1, 2, 3, 4, over 2, 1, 2, 3, 4. And that's my second point. So now I have this point, I have this point, and then I just got to do it for the last set. So on this one, it's going to be over 1, 2, 3, 4, up 1, over 1, 2, 3, 4, up 1. That's twice. 1, 2, 3, 4. Then over 1, 2, 3, 4, up 1. And now we have a triangle, which should look basically like the original triangle that we had, except for it is larger and it's been moved. So we did that once, twice, 3 times. So to dilate something, literally, if it just says dilate it, you're multiplying the numbers. If it says dilate from a point, you are just counting from the point from point P, and then counting 1, 2. And then since it said dilate by 3, you do that a total of 3 times to get to the next one. And that is it. Boom, I can take these goggles off so I can finally see, possibly.